Hello dear students, welcome back. In this video we are going to start with series solution of ordinary differential equation, but particularly we will discuss about that the power series method. So let us see that the second order ordinary linear differential equation y double dash plus p of x y dash plus q of x y is equal 0. So this is our standard form. Now, if the point x is equal x0 is the ordinary point of the equation 1, when we can say if the function p of x and q of x has that the finite quantity as we take the limit x tends to x0, that we will remember, and limit x tends to x0 q of x, if both have the finite quantity, then we can say that the point is nothing but ordinary point of the equation number 1, and hence the power series method is applicable. But what about if the point is not ordinary? That means if it is singular point, x0 is equal 0, that always we will talk about x0 is equal 0, because basically we are solving that the ordinary differential equation, that is x0 is equal 0. Also you can solve x0 is equal 1, 1 by 2, 1 by 3, 1 by 4, 3, 4 and so on. But basically here we will deal with x0 is equal only 0. If x is equal x0 is equal 0 is regular singular point of equation 1, then the Frobenius series method is applicable. So let us see that the first, if the point is the ordinary point of the differential equation, then we will first talk about the power series method. So this is the what outline of this power series method that we have to follow. First, this is our given standard equation, and from this we will verify that the x0 is equal, that 0 is an ordinary point or not. If it is ordinary point, then power series method is applicable. So step number 1, we will see that x0 is equal 0 is an ordinary point. Now step number 2, we have to assume that y is equal summation k is equal 0 to infinite ak x minus x0 raised to k with the solution of the equation number 1. If it is a solution of equation number 1, so it should satisfy its differential equation. So for that, we have to find with y dash and y double dash, that you can see that because we have derivative with respect to x, so only k times ak x minus x0 raised to k minus 1. And similarly, you can write y double dash too. But particularly what we are going to deal with x0 is equal 0. So if I substitute all these values here, so what we are going to get, y is equal summation k is equal 0 to infinite ak x raised to k. Y dash will be summation starting from 1 to infinite k into ak x raised to k minus 1, and summation starting with 2 for the y double dash and k times k minus 1 ak x raised to k minus 2. And this is the thing that we have to always use whenever we have that the power series method is there. So what about the next step? Now it is the solution, so it should be satisfied differential equation. So we are going to substituting here, that means substituting y dash, y double dash and y in the equation number 1, and after that what we have to do, we have to solve. So in that case, first step we will follow that, we will make the same power of x, and after making the same power we will make the same index of the summation, because we want to ultimately compare on the both the side of the coefficient of x. That's why for our simplicity, first we will make the same power of x, and then we will make the same index of summation, and then compare the coefficient of x raised to k on the both the sides, and we will get the recurrence relation. And from the recurrence relation we can find all the constants, and then after we will replace here, and that will be what exactly our final series solution. And this is the same procedure we will follow for the Frobenius, but there is some assumption that we will discuss later on. So this is the step number 7 that already I have said. Now let us move on to the first simple question. Solve in series d square y by dx square plus x square y is equal 0. So this is the equation number 1, and here it is not mentioned that x0 is equal 0, but by default you have to solve this example about x0 is equal 0 with the help of series solution. But here first we have to understand that which method is going to be applied, power series or Frobenius series method. So we have to compare with the standard form. So what we are going to get, P of x is equal 0 and Q of x is equal x square, and both are finite at x0 is equal, that is the 0. So what we can say that this is going to be x is equal, x0 is equal, that is a 0 is nothing but ordinary point, and therefore by power series method. So step number 1 that already we have done. What about the step number 2? We are going to considering that let y is equal summation starting from k is equal 0 to infinite ak x raised to k with the solution of the equation number 1. If it is solution, so we can find y dash and y double dash and we can replace here and it should be satisfies differential equation. So we write that the y dash, so summation k is equal 1 to infinite k times ak x raised to k minus 1, y double dash that is the k times k minus 1 ak x raised to k minus 2 and summation starting from 2 to infinite. Then after step number 3, what we have to do, substitute all these value y dash and y double dash in the equation number 1, and after putting we will get this one. In next step what we are going to consider, x square. I'm just going to consider here, so this will be what, summation ak x raised to k plus 2 summation starting from that is 0 to infinite, that we have written over here that you can see. Now we have, this is the, now what we are going to make, we have to make the same power of x, but here it is not there. But for our simplicity what we are going to consider that I want to make same power, that is x raised to k. Also you can make one of them is keep as it is, and also you can make that the x raised to k minus 2 here. But what I am just going to focus for all the example that just make same power, that is x raised to k that we want. So I have to do just k is replaced by, here k is replaced by k plus 2, and what I have to do, just k is replaced by k minus 2. So just I have replaced here k is equal k plus 2, k is replaced by k plus 2, k plus 2 here, and again you can see that k plus 2 is there, again k is replaced by k plus 2, and like that here k is replaced by k minus 2. So k minus 2 is equal 0, ak minus 2 x raised to k minus 2 plus 2 is equal 0. Now I'm just going to simplify, so this is going to be cancelled out. So summation starting with 0 to infinite k plus 2, k plus 1, k plus 2 x raised to k plus summation starting with what, just take 2 on the right hand side. So summation k is equal to infinite ak minus 2 x raised to k is equal 0. So we have obtained that the x raised to k is the common for all the terms. That means we have two terms and two terms contains the same power, that is x raised to k. Now what I'm just going to focus, I have to make the same index of the summation, but your highest index is k is equal to. So now we can make that this index to k is equal to. So what I have to consider, I have to consider k is equal 0 and 1, and then I will follow k is equal to onwards. So let us first put k is equal 0. So 2 times 1, a2, and x raised to 0, that you know that x raised to 0 is nothing but 1, then plus x k is equal 1, so 1 plus 2, that is going to be 3, 1 plus 1, so it is going to be 2, k is equal 1, so a3 x raised to 1, so it is going to be x, and then after we are going to write that the k is equal to infinite, and whatever we have that we have written over here, and this is the same, there is no change in this term. Now just simplify this one, 2a2 plus 6 times a3x plus summations starting from 2 is equal, k is equal to infinite, and what we can say x raised to k is a common, so I have to put these terms plus these terms, and that it is written over here. But 0 also can be written as that is a 0 series. 0 into x raised to k. Now we are able to compare on the both the sides because 0 can be represented as the 0 series. So you can compare on the both the sides. So what I'm just going to get that the 2 times a2 is equal 0. So from this a2 is equal 0 and 6 times a3 is equal 0. So what we are going to get a3 is equal 0, and this is what exactly our recurrence relation that we can obtain. But here whenever we represent that the recurrence relation, so always we will try that the higher coefficient in terms of the lower. So this is our coefficient, that is ak plus 2 and ak minus 2. So which one is the bigger? So it is clear that ak plus 2 is the bigger. So I will write that the ak plus 2 in terms of ak minus 2, and this will be the minus, and just take this as a division. So this is what exactly recurrence relation. It is valid for k is equal to onwards because our summation starting from 2 to infinite. Now let us move on to the next. So just we replace k is equal to 3, 4 and so on. So let us start with the first k is equal to, but we will remember that previously what we have obtained that a2 and a3 is equal 0 whenever it is required. So we will use that a2 and a3, a2 and a3, and this is what exactly 0. Again you can verify that, yeah, it is there. So now just put k is equal to here, so we will get a4 is equal minus 80 divided by 2 plus 1, that is 3, and 2 plus 2, that is going to be 4, and this is the first a4. K is equal 3, so we will get the a5 is equal minus a1 divided by 4 into 5. So again this is a5. K is equal 4, so a6 is equal minus a2 divided by 5 times 6, that also you can verify. But a2 itself is 0, so this is going to be 0, and k is equal 5, so we will get the a7. Also a3 is 0, so we will get the answer is 0, and k is equal 6, so we will get the a8, and our answer is minus a4 divided by 7 times 8. But a4 is what? But here a4 is nothing but this one, so just replace it here. So minus minus plus a0 divided by 3 times 4 times 7 times 8 and so on. Now what I'm just going to consider, whatever we have assumed that the solution akx raised to k is equal, that is 0 to infinite. Now we are expanding this one, that is a0 plus a1x plus a2x square plus a3x cube plus and so on. Now I'm just going to substitute all these whatever we have that to obtain the coefficient. But whatever we have a2 and a3, this is going to be 0. But here we can replace a3, a4, a5, a6, a7, a8, and that we are going to substitute, and that you can see that this is the a2, a3 0, a4 that is we have, a5 is there, a6 is 0, a7 is 0, a8 is there. So what we can write after simplifying that a0 that contains here, also a0 is there, also a0 is there, so we can write a0 common. So what we are left with, 1 minus 1 divided by 3 times 4 x raised to 4 plus x raised to 8 divided by 3 times 4 times 7 times 8 and minus and so on. But after remaining that, you can see that a1x, this is the first a1x and this is the second, and third term that also we can obtain. But here we have stopped up to x raised to 8 power. So here just take a1 as a common. So what you can see that the x minus x raised to 5 divided by 4 times 5 plus and so on. So this is what y a0 and a1 is nothing but arbitrary constant, and this is what required series solution. So which is required series solution. But also you know that this is also general solution that also you can see, because order is 2 and it should have 2 arbitrary constant in the general solution, and that is we have, and therefore it is going to be what? General solution, or you can say required series solution. Now let us see the another question. So very quickly, Obtain the legendary functions such as solution of 1 minus x square y double dash minus 2xy dash plus 2y is equal 0. First compare with the standard form, and we are obtaining that first x0 is equal 0 is an ordinary point or not. That also you can verify, because x0 is equal 0, so it is going to be 0. This is a finite quantity. Again this is going to be finite quantity. Answer will be 2, and therefore x0 is equal 0 is an ordinary point. Therefore power series method is there. Step number 1, we have assumed that the solution, just we have derived y dash y double dash. Now we are substituting here. So already we have substituted here all this value. So we have this one, but what we are going to follow in the next step, just multiply with 1, then multiply with this, then this also you can see we have just multiplied. In the next step we are going to consider here, also x is going to be considered here. So we have obtained that x raised to k minus 2 plus 2, so this is the x raised to k, and these terms will be x raised to k. X raised to k is there, x raised to k minus 2 is there. In next step what we are going to make, same power of the summation. So this summation must have the same power for our simplicity. So x raised to k is there, x raised to k is there, x raised to k is there. Now you can make, so what you have to do, just k is replaced by k plus 2. So what you are going to get, that k plus 2 is equal to, so 2 will be the cancel out, so summation starting with 0 to infinite, k plus 2, k plus 2 minus 1, so it will be the k plus 1, a k plus 2 and x raised to k, and these are the same that already I have mentioned over here. Now what I have to do, I have to make that the same index. So highest index is nothing but k is equal, that is to that you can say. So I have to make all the index k is equal to onwards. So what I'm just going to consider, just put here k is equal 0 and 1, then it will be the k is equal to onwards. So like that here I have to put that the k is equal 1, and I have to put that k is equal 0 and 1. So this is the first k is equal 0 and 1, so we will get this one that you can see, and you can also verify. This is k is equal to, that is we have, and this is also for k is equal 1, and then after we have started with k is equal to onwards, so that also you can verify. Now last, this is the k is equal 0 and k is equal 1, and then after k is equal to onwards, that is we have. Now what I have to do, I have to first simplify as a first constant, so 2a2, and like that this is the 2a0 is that, plus coefficient of x, so I'm just going to consider this one, and then this one, and then also this one, so you can see that this is going to be cancelled out, plus summation k is equal to onwards. So this is, I'm just going to combine with this, and x raised to k is a common that I'm just writing here. So this is term is there that you can verify. This is the plus minus minus, so it will be minus 2 times k, and this is a plus 2 times ak. And also comparing on the both the sides, so this is going to be a2 is equal minus a0, a3 will be 0, and this recurrence relation we can obtain from this equation. So higher in terms of lower, so we have represented ak plus 2 is nothing but higher than the ak. So we can write just on the right hand side, so it will be the plus, and this is going to be minus. So just multiply with this. So what you are, I'm just writing that k plus 2, k plus 1, ak plus 2 is equal k times k minus 1 ak plus 2 times k ak minus 2 times ak. So what you can write, just verify that the k common, so k into k, that is the k square minus k, and this is the 2k is there minus 2, and divide by whatever it is, so I'm just going to write here. So after simplifying, you can see that the k square plus k minus 2 divided by k plus 1 into k plus 2, and this is the ak is there. Now you can factorize this one, k plus 2 is going to be eliminated, so we will have this one, and this is what recurrence relation, so which is recurrence relation, and using this what you can obtain, k is equal to, so in that case a4, k is equal 3, a5 and so on, and obtaining all these value you can verify whenever it is required. We will use that a2 is equal, that is a2 is equal minus a0 and a3 is equal, that is rule that you can use, and you can find all these constant, and then we will substitute in the assumed solution, and after that we will write as a0, that is the common, and we have that the function, and plus a1 times x, and this is what a0 and a1 are arbitrary constant, and this is the required solution. So in this video we have discussed about the power series method. Thank you.